elementary integrals on your memorize cards or your cardable moments or whatever you want to say. Yeah, it's like you said, the integral of cos and the integral of sine, you probably know that already. But when it's just integral of tan, you could do like we did the last lesson where you changing it into sine over cos and evaluate it that way. But you could just memorize it as well, right? Okay. So let's try the integral of sine 2x plus cos 2x dx. So, do you think this is U-substitution?
No. Oh, wait.
Okay, so it depends on what you're defining U-substitution. It is U-substitution, but essentially you're doing them both separately, and the U is going to be the 2x. Yes. What? You can separate integrals. There's no product rule. Remember, a lot of people got that wrong on the test. But you can separate this. So sine of 2x dx plus cos of 2x dx. And so you could do a general thing and say u is 2x, so du is 2 dx, which is 1/2 du equals dx. You could also do this at the same time and just play around until it worked, right? Because this is a simple enough U-substitution that you could probably play around with it, right? So what's the integral of sine? Yeah, negative. It's right there.
Well, on
right
our
there.
sheet, it's kind of moved, like it's.
Yeah,
Oh, weird. Yeah, make sure you rewrite this on your sheet because something goofy went on. So anyways, minus cos of u. Are we going to do it as u's then? Or are we? Yeah, let's do it. Oh, so then if that's the case, then sorry, I'm skipping a step then. Integral of sine u du with a 1/2 in front plus the integral of cos u du with a 1/2 in front. That's what I'm saying. It might be faster once you get used to, you have that extra 2 in there, to just do it by kind of guessing and playing around with it. So the integral of sine u would be minus cos u with a 1/2, I guess, right? And the integral of cos u would be sine u plus c, I guess. And then you got to put it back. So what I guess I'm trying to say is this takes a lot of work to do U-substitution. If you know that 2x is going to be your u, and you can mentally do this, you might just go directly to that step, right? You know what I'm saying? You don't know what I'm saying?
No. I just,
You think you'd have to do, I think if you practice it enough times and you, just think, I'm just saying, the reason why I'm saying that is you got to have lots of speed, right? And so if this is a multiple choice, you're only allowed like a minute or so a question. So, yeah. So anyways, anytime you can skip some steps, you can, right? So, okay. So this is just, it has a basic trig. There you go. Is this as one of the 6 trig function squared? So if it happens to be written like this, it's cosecant squared 3x. How would you do this? Yeah, so when it's secant squared, remember the thing, there's a secant squared that's pretty easy. It just goes to tan, and the cosecant squared, it just goes to the minus cotangent, right? So you're supposed to recognize this as one of those.
so just looking at the
But then you have a 3x. So,
1/3 maybe?
yeah, see, once you do this once, you'll know how to do this, right? So I'm going to write it out. So I'll say u equals 3x du would be, you probably could even go 1/3 dx, right? Like, can you skip that step at this point? Probably, yeah. Okay. So then this would be, again, I'm going to show all the steps, but I'm saying you could probably already know what this is going to be. this is the integral of cosecant squared u du with a 1/3. So then this is 1/3 tan u plus c, which is 1/3 tan. Oh, sorry. Oh. Yeah, and it's negative, and it's negative. I'm totally doing it wrong. I was looking at that one going, ah, okay. Cotangent u with a 1/3 plus c. So this is negative 1/3 cotangent 3x plus c. But I'm saying you probably already knew that was going to be that, and you would have went directly there. Do you know what I'm saying? Like, this is a lot of extra steps doing the u in there. No?
Yeah.
It could be.
I mean, if there's an easier way, sure.
You access it at 3x. You know when you're finding that antiderivative and you bring it down, access like the 3x is what you bring down.
Right, like, so, and again, you can always check. That's why I'm saying you might almost, once you do enough of these, you know it's going to be 1/3. You can go directly to this step and then find the derivative of this step and make sure it's right, instead of doing all the in-between. You know what I'm saying? So then you'll save a little bit of time. So the derivative of cotangent and cosecant squared of the same thing, and then times 3. So that's how the 1/3 goes away. And the negative, right? Make sense? Okay. Is it just an identity? Remember all these identities? So cotangent of 3x. Now, if you remember, do you see cotangent's on here? If you memorize it, all good. I have a feeling there's so much to memorize you might forget it. Okay? So here is cotangent 3x. So how could we do this? Yeah, we could rewrite this as cos 3x over sine 3x. And then what are we going to let our u be? Anybody? Oh, and I forgot the dx, sorry. What's my u going to be? No, not 3x. Because the problem is I have there's two functions here. No, we're not going to do the top, because the derivative of cos is sine, but it's sine's on the bottom, so it's easier to do the bottom to have the leftover on top, right? Sine 3x, so du would be, derivative of sine is cos of the same thing, derivative of the inside, which is a 3. Does everybody see? Oh, and a dx, right? So there is my, that part, the extra. So I don't want that 3 there. Yes? So 1/3 du. And again, you don't have to show this step, but I am going to show this step. Because that's a way to skip some steps to save time, right? You know that you have to have that 1/3 in there. So this would be 1/3. This whole thing gets replaced with du, and then this would be over u. So what is that?
Well, it's just 1 over u.
1 over u, yeah. If you want, I can move it as 1 over u. 1 over u du. So yeah, the integral of 1 over u is the logarithm, natural logarithm, right?
The absolute value of sine.
Yeah, so this would be 1/3 the natural logarithm of the absolute value of u plus c. Again, you could skip this step at this point and just put cos directly in, right? So equals 1/3 the natural logarithm of cos 3x plus c. So if you look, oh yeah, no. What the heck? What the heck? Sine 3x plus c. See? You guys are catching my mistakes now. So if I would have memorized this, I would have had this already in there, and my u would have been the 3x. Do you see what I'm saying?
Always put the fraction in front of the ln or the, like, farthest still less, right? The fraction, because you put the 1/3 in front of the ln, you never put it inside that.
No. Because this is what you're, this is what becomes this, right? So the 1/3 is kind of just smooshed down. However, if there could be, this 1/3 means the cube root inside. That might be a choice on your multiple choice, but this would be an acceptable answer, right? Like if this was the long response. Well, yeah, because if you memorize this one here, do you see, then the u would be, and then you'd have the 1/3. Yeah, okay. Do you remember these trig identities? You probably remember sine squared plus cos squared as 1, but you probably forgot these ones. You might want to put those on your cards. However, do you remember that it's really easy to figure out, though, if you forgot? I showed you this when I taught you these. Everybody remembers sine squared x plus cos squared x equals 1, right? Say you forgot these ones and you were in like a pinch. I know I can't remember if it's whatever. So how do I make tan squared out of sine squared? I divide everything by cos squared. And do you see what I get there as my identity? This is my tan plus 1 equals secant. Do you see what I'm saying? Easy. And then if I do, yeah, so for cotangent, I write cos squared plus sine squared x equals 1. And I divide by, sine squared this time. Sine squared x. I know, what's going on here? It's Friday. So this is my cotangent plus 1 equals cosecant squared. So if you ever forget, you could pretty much figure it out pretty fast, right? Now that you remember this now. I did show you this back in the day, but I know you probably forgot. So here's the thing. Cotangent squared, we don't know the integral, but we do know cosecant squared. What's the integral of cosecant squared? Yeah, minus cotangent, right? Because the derivative minus cotangent is cosecant squared. Remember the CCC? I know, this is why it's hard, because you're thinking is it derivative or anti-derivative or whatever. So, if I rewrite this in terms of this, do you see what I'm saying? So this would be the integral, move this 1 over, of course. So this would be cosecant squared 3x plus, sorry, it wouldn't be plus 1, it would be minus 1 dx. Does everybody see what I did there? I can't evaluate cotangent squared, the integral, okay? But I do know cosecant squared. So if I rewrite this as cosecant squared, then this is much easier to evaluate. Because the integral of cosecant squared is negative cotangent. Now, could you do this without U-substitution? Like, you can do U-substitution, but do it as a shortcut now. We've done this enough times. You know what it's going to be, right? You don't. The 3x is your u, right? And then that becomes the 1/3. Bada bing, what, you know what I'm saying? So then what is this equal to? Do you want me? Negative 1/3 cotangent 3x. Yeah, minus?
Yeah.
And, well, no, you have to integrate 1.
So that'd be
Minus x plus c. What do you think? Do you want me to do the steps in between, or did I lose you?
Yeah.
All I did here is I did a u substitution for this. So if u is 3x, then du would be 3 dx, which is 1/3 du is dx, right? So then the integral of cosecant squared u, right? Instead of the dx, I'm going du with a 1/3. No, you don't need to write it down if you understand this part, right? So, and by the way, I was only doing U-substitution for this one. This one I can do, like, it's easy, right? What's the integral of 1? Yes. So essentially what I'm doing here, I'm going to go over here. What I'm doing here is I'm splitting them up.
It's not nice.
Otherwise, I would have to replace the dx with the du, and I'd still have that, and then I'd have an extra 1/3 with an x, but at the same time,
There you go.
no, I wouldn't do that because there's no u in here, so why would you like you know what I'm saying? Like you just separate them and treat them separately. That's more what you should do. Like I think you're doing. You shouldn't do more work than you have to. This is an easy integral you should just evaluate, right? And then this one I do it with the U-substitution. Kind of like I did over here. I separated them and did simultaneous U-substitution. Make sense? But at this one, I'm not doing simultaneous U-substitution. I'm doing this with U-substitution and this one without U-substitution. Yeah.
Okay. So if you're going to use substitution, you do both.
Right. Okay, next page. It's saying never leave a lone trig function in a denominator. Replace it with its reciprocal. So what would this be?
Squared 2x the integral, yeah. Yes. And then you just do the 1/2 and 2x plus c.
It's getting easy now, hey? No?
For this one, yeah.
For this one. Does everyone understand that the root of 10 is secant squared? This is an easy one, right? So the integral of secant squared is 10 of the 2x. And what did we do when we make this a u? This would become a half.
Okay, it's one of the derivatives on the integral of that thing with the middle part.
And then I'll be like,
What do you think?
I'll get it.
Yeah? Okay, this is something we did not discuss in, we didn't discuss in grade 12 pre-cal. However, at the same time, we did have cos 2x identities. So this is cos 2x identity in disguise. So do you remember what cos 2x was actually equal to? There was 3 of
I
them.
remember that there was 3.
There was 3.
1 plus cos squared x or something?
So if I manipulate,
Wait, I got a formula sheet here.
so if I manipulate this, for instance, you'll probably recognize this. If I get rid of the 1/2 by cross multiplying that over, I get 2 cos squared x equals 1 plus cos 2x. This is the one you remember. Cos 2x equals 1 minus, 2 cos squared x minus 1. And this one you probably remember. If I cross multiply it over, I get 2 sine squared x equals 1 minus cos 2x. So cos 2x equals 1 minus 2 sine squared x. So these are the ones we remember from grade 12. I know you didn't memorize it in grade 12. It was on your formula sheet. But you actually have to have them memorized. So this is just manipulated so that you can actually integrate this. So here's the thing. Out of all the questions on the exam, this might be one out of the, I don't know, 100 questions or whatever, or 80.
Yeah.
So you might have the attitude where, oh, I'll just get that one wrong. I won't take the time to memorize how to do this. But at the same time, it's funny how many times you'll say that when you start memorizing things. Oh, I'll just get that one wrong, or I'll just get that one wrong. Then it starts accumulating, and you have a bunch of things that you don't know. You know what I mean? So if you can remember this class and me saying all this. Oh, I remember this is like a double angle, whatever. Maybe you'll remember this. I don't know. So what you're supposed to do is if you see a cos squared x, you're supposed to replace cos squared x with 1/2 times 1 plus cos 2x. And of course, when you put this in an integral, the 1/2 will go outside the integral. So then this just becomes 1/2 the integral of 1 plus cos 2x dx. Does everybody see what I just did? So then this is easy now, right? Because cos 2x, the 2x, you're just going to use as a U-substitution, right? And what's the integral of 1? What's the integral of 1? X. And then what's the integral of cos 2x? 1/2 sine 2x plus c. And you might argue, oh, I need to multiply that out, and maybe the multiple choice is multiplied out, so you get 1/2 x plus 1/4 sine 2x plus c. Yeah? I'm just trying to show you anything that could be asked. That doesn't mean like you're going to have multiple questions of this. So on the U of W course, they would ask lots of these actually. So if you take the U of M or the U of W course, the second part, the second semester part, will have lots of these. Whereas the AP exam, they might throw one on every couple of years, or maybe, you know what I mean? Like, so it's up to you. Okay, so this one's a little harder one. So do you see how we have these things here? You have to put both in, yeah. Because U-substitution is easy with the 2x. So if they're both with the 2x, then it's pretty easy to go. So what I would do is, like I said, this might be on a long response because this is more than just a multiple choice question, right? So I might change, this is my aside, my scrap paperwork. I'm not going to worry about the integral and that stuff. Sine squared x cos squared x. This becomes 1/2. And what is the sine squared? It's 1/2, well, the sine squared is 1 minus cos 2x, right? And then this would be 1/2, and this is 1 plus cos 2x. So this is really not much to memorize because of the fact that it's the same thing, just one's a plus, one's a minus. So remember that the cos squared is the plus, and you're way to go. And really, in the end, if you remember half of this somewhat, you could maybe narrow down a multiple choice, right? So I'm just going to multiply this, so this is 1/4. And just like Josh said, this is difference of two squares, right? So 1 times 1 is 1. The outer and the inner will cancel, and then I get cos of squared 2x. And then we're in a dilemma again. Huh? Now we're back to a cos squared. So we got to do it again. So it's up to you whether you want to do the quarter in and deal with the one later or put it in that way. It's up to you. So I'm going to leave it the way it's written. 1 minus, remember this gets replaced with, now watch now. This has got a 2x. It's not cos squared x. So what does that mean? 1/2 1 plus cos 2x. But the 2x, this is like the u or whatever. So then what does this become? It doesn't become 2x if it was already 2x. It would be, what are you saying? A 4x, yes? Well, I didn't hear you, that's what I'm saying. 2 times 2. Essentially, you're putting, wherever this x is, you're putting a 2x. So if this was already a 2x, then you're putting a 2x where that x is. So that gives you a 4x. Like I said, this is like a slim chance that you'd ever get asked this, but I'm going to show you how to do it just in case. You take your chances there, Rachel. So 1/4 times 1 is 1/4. 1/4 times 1/2 is 1/8, so minus 1/8. 1/4 times 1/2 times cos 4x would be plus 1/8 cos. I'm multiplying this out. So then I would, right? What do I get there? 1/8. So this is 1/8 plus 1/8 cos 4x. Now I'm going to actually do the question. Yes, you're right. Is a minus, so this should be a minus, so this should be a minus. I haven't actually started the integral yet. I just simplified it enough so I could tackle the integral.
Now you can actually do the integral.
Yes. Okay. So this is equal to the integral of 1/8 minus 1/8 cos 4x dx. So you guys wanted to try that one?
Is it it's a minus now?
Well, it was a minus. I dropped my minus when I did like that. Josh caught that.
Well, I didn't change that, so.
Okay. Oops, I'll put it up so you can see. So, Riley, what do I get for the integral of 1/8? 1/8 x. Very good. Okay, so can you do this U-substitution in your head now?
So 1 over negative 1 sorry, sine 4x plus e.
What do you think of that? Starting to make sense?
I think I could actually make it.
But it's like the only thing that you ever had to do in your head was just a 4 times thing.
The 1/4.
Well, I mean, like,
The 1/4 times 1/8 is the 1/32. Yeah. Yeah. Word.
Sine of 0, 0. Sine of pi over 2.
This one's actually an easy one. You can do it in about 2 seconds.
Oh, done.
Seriously.
I didn't think I did 1.9.
This is definitely on the exam for sure, because this is pretty straightforward. This is U substitution at its finest. What's U going to be? U would be sine x. So du would be cos x dx, which is this part right here. No, like that's the hard part about this course is I do little baby things and then I throw them all together and they become massive and it's like, oh my gosh. So so this would be the integral. Now we have to change our upper and lower limits then, right? What's sine of 0?
0 and 1.
No. You would lose marks if you do it later. You can't have the.
Oh, I thought you were saying no. That's what I said.
So sine of pi over 2.
I've been showing my work wrong.
That's why I thought you were saying no.
I guess I
Huh?
have been showing my work wrong.
So what's this integral going to be? 1 over 6 u to the power 6 from 0 to 1. So it's 1/6. Does everybody see it's going to be 1/6 because if you subtract 0 and all that good stuff?
The power 6.
Yeah. Okay, I'm not going to say anything about the next one. Do you think you could figure it out?
I fixed those would be divided what? No, 3. That's still wrong.
This one's a tricky one. It makes you really think, actually. It is U-substitution at its finest, but I'll give you a hint. You need to split up the cube.
Times cos x. Cos x times cos x times cos x.
No, not cos x. Think a little differently than cos times cos times cos. Split up the cube
Sine
to two things.
times
Why would it be sine squared x, though? If I split up the cube, it would just be...
sine squared.
Hold on. Okay, well, you're a little bit off a little bit, too. 1 minus. Yeah. Okay, I'm going to show each step here, but you might be able to skip steps if you understand this. So this would be the integral of cos squared x times cos x dx. But then change this, and you might do this in the same step, that's what I'm saying, as 1 minus sine squared x cos x dx. Now you don't have to change sine squared x into the half angle. That would be too much work. You could, but if you recognize that you make sine x u, then this leftovers would be the derivative of that, right? So you want to finish it off? You know what I'm saying there, Matthew? Let u equal sine x, so du would be cos x dx, which is this part. What's that? Yeah, so anyways, so this would be the integral of 1 minus u squared du. Yeah? So the integral of 1 with respect to u, like this, you can't separate it once you've now, like you're changing this whole thing. This is different than what Cruz was asking before, right? This one is, do you see what I'm taking this whole thing? I can't really separate it because the cos x would be an extra thing and whatever. Anyways, so the integral of 1 with respect to u would be u, yes? And then this is minus 1/3 u cubed plus c. So then my u is sine x, so this is going to be sine x minus 1/3 sine cubed x plus c.
You could multiply in the cos and then split it?
You could.
Yeah.
You could totally multiply this in and then separate it if you wanted, but you'll get the same result, right? Because the integral of cos is sine. So either way, you'll get that answer, right? So.